That was pretty incredible, right? But that was you. That was you. Thank you. Well, Taiwan doesn't just build supercomputers for the world. Today, I'm very happy to announce that we're also building AI for Taiwan. And so today we're announcing that Foxconn, Taiwan, the Taiwanese government, NVIDIA, TSMC, we're going to build the first giant AI supercomputer here for the AI infrastructure and the AI ecosystem of Taiwan. Thank you. Is there anybody who needs an AI computer? Any AI researchers in the audience? Every single student, every researcher, every scientist, every startup, every large established company, TSMC themselves does enormous amounts of AI and scientific research already. And so Foxconn does an enormous amount of work in robotics. I know that there are many other companies in the audience, I'm going to mention you in just a second, that are doing robotics research and AI research. And so having a world-class AI infrastructure here in Taiwan is really important. All of that is so that we could build a very large chip. And NVLink and Blackwell, this generation, made it possible for us to create these incredible systems. Here's one from Pegatron and QCT and Wistron and Wiwynn. This is from Foxconn and Gigabyte and ASUS. And you can see the front and the back of it. And its entire goal is to take these Blackwell chips that are, you could see how big they are, and turn it into one massive chip. Now, the ability to do that, of course, was made possible by NVLink. But it understates the complexity of the system architecture, the rich software ecosystem that connects it all together, the entire ecosystem of 150 companies that came together to build this. This architecture and the entire ecosystem in technology, in software, in industry has been the work of 3 years. This is a massive industrial investment. And now, we would like to make it possible for anybody who wants to build data centers. It could be a whole bunch of NVIDIA GB200s or 300s and accelerated computing systems from NVIDIA. It could be somebody else. And so today, we're announcing something very special. We're announcing NVIDIA NVLinkFusion. NVLinkFusion is so that you can build semi-custom AI infrastructure. Not just semi-custom chips, because those are the good old days. You want to build AI infrastructure. And everybody's AI infrastructure could be a little different. Some of you could have a lot more CPUs, and some of it could have a lot more NVIDIA GPUs, and some of it could be somebody's semi-custom ASICs. And those systems are so insanely hard to build. And they're all missing this one incredible ingredient. This incredible ingredient called NVLink. NVLink so that you could scale up these semi-custom systems and build really powerful computers. And so today we're announcing the NVLinkFusion. NVLinkFusion kind of works like this. This is the NVIDIA platform, 100% NVIDIA. You got NVIDIA CPU, NVIDIA GPU, the NVLink switches, the networking from NVIDIA called Spectrum-X or InfiniBand, NICs, network interconnects, switches, and all of the entire system, the entire infrastructure built end to end. Now, of course, you can mix and match it if you like, and we now today make it possible for you to mix and match it even at the compute level. This would be what you would do. using your custom ASIC. And we have great partners I'll announce in a second who are working with us to integrate your special TPU or your special ASIC, your special accelerator. And it doesn't have to be just a transformer accelerator. It could be an accelerator of any kind that you would like to integrate into a large scale-up system. We create an NVLink chiplet. It's basically a switch that abuts right up to your chip. There's IP that will be available to integrate into your semi-custom ASIC. And then once you do that, it fits right into the compute boards that I mentioned, and it fits into this ecosystem of an AI supercomputer that I've shown you. Now, maybe what you would like is you would like to use your own CPU. You've been building your own CPU for some time, and maybe your CPU has built a very large ecosystem, and you would like to integrate NVIDIA into your ecosystem. And now we make it possible for you to do that. You could do that by building your custom CPU. We provide you with our NVLink chip-to-chip interface into your ASIC. We connect it with NVLink chiplets, and now it connects and directly abuts into the Blackwell chips and our next generation Rubin chips. And again, it fits right into this ecosystem. This incredible body of work now becomes flexible and open for everybody to integrate into. And so your AI infrastructure could have some NVIDIA, a lot of yours. A lot of yours, you know, and a lot of CPUs, a lot of ASICs, maybe a lot of NVIDIA GPUs as well. And so in any case, you have the benefit of using the NVLink infrastructure and the NVLink ecosystem, and it's connected perfectly to Spectrum-X. And all of that, you know, is industrial strength and has the benefit of an enormous ecosystem of industrial partners who have already made it possible. So this is the NVLinkFusion. Whether you buy completely from us, that's fantastic. Nothing gives me more joy than when you buy everything from NVIDIA. I just want you guys to know that. But it gives me tremendous joy if you just buy something from NVIDIA. And so we have some great partners. L-Chip, AsteraLabs, Marvell, and one of our great partners, MediaTek, are going to be partnering with us to work with ASIC or semi-custom customers, hyperscalers, who would like to build these things, or CPU vendors who would like to build these things, and they would be their semi-custom ASIC provider. We also have Fujitsu and Qualcomm who are building their CPUs with NVLink to integrate into our ecosystem. And Cadence and Synopsys, we've worked with them to transfer our IP to them so that they can work with all of you and make that IP available to all of your chips. So this ecosystem is incredible, but this just highlights the NVLinkFusion ecosystem. Once you work with them, you instantly get integrated into the entire larger NVIDIA ecosystem that makes it possible for you to scale up into these AI supercomputers. Now let me talk to you about some new product categories. As you know, I've shown you a couple of different computers. However, in order to serve the vast majority of the world, there are still some computers that are missing. And so I'm going to talk about them. But before I do that, I want to give you an update that, in fact, this new computer we call DGX Spark is in full production. DGX Spark will be ready, will be available shortly, probably in a few weeks. We have tremendous partners working with us: Dell, HPI, ASUS, MSI, Gigabyte, Lenovo. Incredible partners working with us. And this is the DGX Spark. This is actually a production unit. This is our version. However, our partners are building a whole bunch of different versions. This is designed for AI native developers. If you're a developer, you're a student, you're a researcher, and you don't want to keep opening up the cloud and getting it prepared, and then when you're done scrubbing it, okay? But you would just like to have your own, basically your own AI cloud sitting right next to you, and it's always on, always waiting for you. It allows you to do your prototyping, early development, and this is what's amazing. This is DGX Spark. It's 1 petaflops and 128 gigabytes. In 2016, when I delivered DGX1, this is just the bezel. I can't lift the whole computer. It's 300 pounds. This is DGX1. This is 1 petaflops and 128 gigabytes. Of course, this is 128 gigabytes of HBM memory, and this is 128 gigabytes of LPDDR5X. The performance is, in fact, quite similar. But what's most important is that the work that you could work on this is the same work you could do here. It's an incredible achievement over just the course of about 10 years. Okay, so this is DGX Spark for anybody who would like to have their own AI supercomputer. And it's, I'll let all of our partners price it for themselves, but one thing for sure, everybody can have one for Christmas. Okay, I've got another computer I want to show you. If that's not enough, and you would still like to have your own personal, thank you, Janine. This is Janine Paul, ladies and gentlemen. If that one isn't big enough for you, here's one. This is another desk side. This is also going to be available from Dell and HPI, ASUS, Gigabyte, MSI, Lenovo. It'll be available from Box, from Lambda, amazing workstation companies. And this is going to be your own personal DGX supercomputer. This computer is the most performance you can possibly get out of a wall socket. You could put this in your kitchen, but just barely. If you put this in your kitchen and then somebody runs the microwave, I think that's the limit. And so this is the limit. This is the limit of what you can get out of a wall outlet. And this is a DGX station. The programming model of this and the giant systems that I showed you are the same. That's the amazing thing. One architecture, and this has the ability, enough capacity and performance to run a 1 trillion parameter AI model. Remember, Llama is Llama 70B. A 1 trillion parameter model is going to run wonderfully on this machine. Okay, so that's the DGX station. So now let's talk about, remember these systems are, thank you, Jenny. These systems are AI natives. They're AI native computers. They're computers built for this new generation of software. It doesn't have to be x86 compatible. It doesn't have to run traditional IT software. It doesn't have to run hypervisors. It doesn't have to run it doesn't have to run Windows. These computers are designed for the modern AI native applications. Of course, these AI applications could be APIs that can be called upon by the traditional and the classical applications. But in order for us to bring AI into a new world, and this new world is enterprise IT, we have to go back to our roots, and we have to reinvent computing and bring AI into traditional enterprise computing. Now, enterprise computing, as we know, is really 3 layers. It's not just the computing layer. It's compute, storage, and networking. It's always compute, storage, and networking. And just as AI has changed everything, it stands to reason that AI must have changed compute, storage, and networking for enterprise IT as well. Well, that lower layer has to be completely reinvented, and we're in the process of doing that. I'm going to show you some new products that unlocks enterprise IT for us. It has to work with the traditional IT industry, and it has to add a new capability. And the new capability for enterprise is agentic AI. Basically, digital marketing campaign manager, a digital researcher, a digital software engineer, digital customer service, digital chip designer, digital supply chain manager, digital versions, AI versions of all of the work that we used to do. And as I mentioned earlier, Agentic AI has the ability to reason, use tools, work with other AIs. So in a lot of ways, these are digital workers. They're digital employees. The world has a shortage of labor. We have a shortage of workers. By 2030, by about 30 to 50 million shortage. It's actually limiting the world's ability to grow. And so now we have these digital agents that can work with us. 100% of NVIDIA software engineers now have digital agents working with them so that they can help them, assist them in developing better code and more productively. And so in the future, you're going to have this layer, that's our vision. You're going to have a layer of agentic AIs, AI agents. And so what's going to happen to the world? What's going to happen to enterprise? Whereas we have HR for human workers, we're going to have IT becoming the HR of digital workers. And so we have to create the necessary tools for today's IT industry, today's IT workers, to be able to manage, improve, evaluate a whole family of AI agents that are working inside their company. And so that's the vision of what we want to build. But first, we have to reinvent computing. Remember what I said. Enterprise IT works on x86. It runs traditional software, such as hypervisors from VMware or IBM Red Hat or Nutanix. It runs a whole bunch of classical applications. And we need to have computers that do the same thing while it adds this new capability, called Agent AI. And so let's take a look at that. Okay, this is the brand new RTX Pro Enterprise and Omniverse server. This server can run everything. It has x86, of course. It can run all of the classical hypervisors. It runs Kubernetes in those hypervisors. So the way that your IT department wants to manage your network and how they want to manage your clusters and orchestrate workload works exactly the same way. It has the ability to even stream Citrix and what other virtual desktops to your PC. Everything that runs in the world today should run here. Omniverse runs on here perfectly. But in addition to that, this is the computer for enterprise AI agents. Those AI agents could be only text. Those AI agents could also be computer graphics. Little TJs, coming to you, little toy Jensens coming to see you, helping you do work. And so those AI agents could be either in text form, it could be in graphics form, it could be in video form. All of those workloads work on this system. No matter the modality, every single model that we know of in the world, every application that we know of should run on this. In fact, even Crysis works on here. Okay, so anybody who's a GeForce gamer? There are no GeForce gamer in the room. Okay, what connects these 8 GPUs, the new Blackwell RTX Pro 6000s, is this new motherboard. This new motherboard is actually a switched network. CX8 is a new category of chips. It's a switch first, networking chip second. It's also the most advanced networking chip in the world. This is now in volume production, CX8. In the CX8, you plug in the GPUs. The CX8s are in the back. PCI Express connected here. CX8 communicates between them. And the networking bandwidth is incredibly high at 800 gigabits per second. And this is the transceiver that plugs into here. So each one of these GPUs have their own networking interface. All of the GPUs are now communicating to all of the other GPUs on east-west traffic. Incredible performance. Now, the surprising part is this, how incredible it is. So this is RTX Pro. This is the performance, and I showed you guys at GTC how to think about performance in the world of AI factories. The way to think about this is throughput. This is tokens per second, which is the y-axis. The more output your factory, the more tokens you produce, okay? So throughput is measuring tokens per second. However, every AI model is not the same. And some AI models require much more reasoning. And so you need those AI models, you need the performance per user to be very high. So the tokens per second per user has to be high. And this is the problem with factories. Factories either like to have high throughput or low latency, but it doesn't like to have both. And so the challenge is how to create an operating system that allows us to have high throughput, the y-axis, while having very low latency, which is the y-axis, interactivity, tokens per second per user. And so this chart tells you something about the overall performance of the computer, of the overall computers of the factory. Look at all of those different colors. It represents the different ways you have to configure all of our GPUs to achieve the performance. Sometimes you need pipeline parallelism. Sometimes you want expert parallelism. Sometimes you want a batch. Sometimes you want to do speculative decoding. Sometimes you don't. And so all of those different types of algorithms have to be applied separately and differently depending on the workload. And the Pareto, the outside area, the overall area of that curve represent the capability of your factory, okay? And so notice something. Hopper is this is the most famous computer in the world, Hopper H100, the HGX, $225,000. Hopper is down there. And the Blackwell server you just saw, the enterprise server, is 1.7 times its performance. But this is amazing. This is Llama 70B. This is DeepSeek R1. DeepSeek R1 is 4 times. Now the reason for that, of course, the DeepSeek R1 has been optimized, and the DeepSeek R1 is genuinely a gift to the world's AI industry. The amount of computer science breakthrough is really quite significant and has really opened up a lot of great research for researchers in the United States and around the world. Everywhere I go, DeepSeek R1 has made a real impact on how people think about AI and how think about inference and how to think about reasoning AIs. They've made a great contribution to the industry and to the world. And so this is DeepSeek R1. The performance is 4 times the state-of-the-art H100. That kind of puts it in perspective, okay? And so if you're building enterprise AI, we now have a great server for you. We now have a great system for you. It's a computer you could run anything on. It's a computer that has incredible performance. And it, whether it's x86 or AI, all of it runs. Okay, our RTX Pro server is in volume production across all of our partners in the industry. This is likely the largest go-to market of any system we have ever taken to market. So thank you very much. The compute platform is different. The storage platform is different. And the reason for that is because humans query structured databases like SQL. People query structured databases like SQL. But AI wants to query unstructured data. They want semantic, they want meaning. And so we have to create a new type of storage platform. And this is the NVIDIA AI Data Platform. On top, just as SQL servers, SQL software, and file storage software from your storage vendors that you work with, there's a layer of very complicated software that goes with storage. Most storage companies, as you know, is mostly a software company. That software layer is incredibly complicated. And so on top of a new type of storage system is going to be a new query system we call IQ, NVIDIA AIQ or IQ. And it's really state-of-the-art, it's fantastic. And working with basically everybody in the storage industry. Your future storage is no longer CPUs sitting on top of a rack of storage. It's going to be GPUs sitting on top of a rack of storage. And the reason for that is because you need the system to embed, find the meaning in the data, in the unstructured data, in the raw data. You have to index, you have to do the search, and you have to do the ranking. So that process is very compute intensive. And so most storage servers in the future will have a GPU computing node in front of it. It's based on the models that we create. Almost everything that I'm about to show you starts with great AI models. We create AI models. We put a lot of energy and technology into post-training of open AI models. We post-train these AI models with data that is completely transparent to you. It is safe and secure data, and it's completely okay to use to train, and we make that list available to you to see. And so it's completely transparent. We make the data available to you. We post-train the models, and our post-trained model performance is really incredible. It's right now, downloadable open source reasoning model. The Llama Nemotron reasoning model is the world's best. It's been downloaded tremendously. And also, we also surround it with a whole bunch of other AI models so that you can do what is called IQ, the retrieval part of it. It's 15 times faster than what's available out there, 50% better query results. And so these models are available, all available to you. It's blueprints are, the IQ blueprint are open source. And we work with the storage industry to integrate these models into their storage stack, their AI platform. This is vast. This is what it looks like. I'm not going to go into it. I just want to give you a texture of the AI models that are integrated into their platform. Let's take a look at what VAST has done.